Wagwan people, and welcome back to the next episode in this series, which is looking at the electromagnetic radiation from stars. Onwards. Keep forgetting to do that, but anyway, stars do, well, the core of a star emits a continuous spectrum of light, a continuous electromagnetic spectrum, right from, like, gamma rays all the way to radio waves. It's all emitted. This radiation is emitted due to the photoelectric effect, as you would know from chapter 4, yeah? And basically, each atom has its own emission line spectrum, though when it undergoes the photoelectric effect, it will emit those lines of light. So, a single hydrogen atom will not emit a continuous spectrum, but due to things we'll talk about later, a star's core will. So, as I say here, because photons in stars are continuously being absorbed and released by atoms, this sort of will then cause a continuous spectrum to be formed, as different photons with different energy levels are hitting different atoms and continuous spectrums happen. Not really unfortunately, quite fortunately, on Earth, we do not see a continuous spectrum. This is because there is hydrogen and helium in the Sun's gaseous atmosphere which don't undergo fusion. These atoms will absorb the photons released by the Sun's core, and an electron will move from a high energy level to a lower energy level. This will cause the previously said emission from, let's say, a hydrogen atom to become black lines in the spectrum emitted from the Sun's core, and these become very, very, very useful. So, but to actually detect this on Earth, because when we look around, we can't go, oh, well, that 4.98 nanometers wavelength is missing, can we? No, we can't. So what we have to do is we have to use a diffraction grating. We know that, well, I'm not going to explain to you what a diffraction grating is, because this has all been discussed previously in chapter 4, but basically, by looking at the distance between by looking at, like, the angle between how we have the wavelengths, we can basically work out dark spots in the spectra on the diffraction grating. We could work out what wavelengths those were, which could basically then tell us where. Well, it could tell us many things, like that stars are made up of hydrogen and helium. We know that, but it could be used to tell us that. What's more useful is looking at the change in lambda and redshift to work on Hubble's law and stuff, and that is what we are looking at in the next episode. So thank you very much for watching, and bye bye.